what we're looking for, but we had to start planning it and building it even several years before this.
Right, exactly. It's great to see that we are here on this day for launch. Thank you so much for joining us, Administrator Nelson. Jim and Megan, back to you.
And we just heard that call out for stage 1 RP loading. Okay, we're coming up on another major fueling milestone now. Let's check back in with Daryl and Mick.
That's right, Megan. Stage 1 RP load complete, and so that completes the stage 2, rather.
Stage 2.
Complete. But we're continuing to load RP1 in the first stage boosters as well as LOX, which is the long pole in the tent. And as we look at this view from our Kennedy Flight Operations team and their Airbus H-135 helicopters, which are out there for security purposes, and they have a camera on board, thankfully for us, you can see the LOX clouds surrounding the rocket, which it's quite a humid day here in Florida today, Mick, so it really stands out dramatically.
Yeah, that cloud is caused from that boil-off we talked about, Daryl, that once we start loading, that cold locks into the vehicle. We get boil-off that occurs to allow the venting of the tanks so that we can get as much LOX into the tank as possible for today's mission. We want all of that propellant to be able to get Psyché on its way on that trajectory that Charmaine talked to you about.
Speaking of LOX, we are getting ready to start loading LOX into stage 2 of the rocket, the upper part. And you can see that
Stage 2 LOX load has started.
And there's the call out. You can see that the strongback has been chilled as well. Now LOX is flowing up to the second stage of the rocket.
Yeah, now this will be the last and final propellant we need to get on board the Falcon Heavy this morning. We continue to load RP1 and LOX onto the first stage, and now that we've started stage 2 LOX, everything will be complete. Daryl, I did want to say Jim is excited to be answering the questions of those kids today. Me personally here in Brevard, I got Miss Stafford's class watching you and I today out at Saturn Elementary, and they're excited to be watching what we're doing.
Well, we thank them and all students who are tuning in today. We are hoping to have a liftoff here, and everything looks good for a T0 at 10:19 and 43 seconds a.m. Eastern Time, 14:19:43 UTC time. We will continue to track the tanking of this rocket, and we'll be back at T-minus 8 minutes to count down to liftoff. In the meantime, we'll send it back to Megan and Jim.
Now, once the Psyché spacecraft is deployed today, it's going to take 6 years to arrive at the Psyché asteroid. Why is that? Why so long?
Space is big, right? We live in a big solar system, and it takes a long time to travel between planets. 3 days to the moon, 6 months to a year to get to Mars or more. And so we are going on this looping trajectory from the Earth all the way out to Mars. We have to pass by Mars and get a little gravity boost from Mars. But then from there, we need to keep going out into the main asteroid belt, not all the way to Jupiter, but to about 3 times as far that the Earth is from the sun. And so it is just a long voyage, and it takes a long time to get there.
Yeah, and when the spacecraft gets there, it's going to observe the asteroid from different orbits, right?
Yes, so we will, you know, this is a model of Psyché. We don't know that the asteroid really looks like this. We don't know it's exactly this size. We don't know its mass to great accuracy, right? So we're going to very cautiously approach it and get captured in its gravity in a very high orbit that's something like 33 hours long, and really start to characterize it, get to know the place. Hey, look, we're here. Let's get to know the place, right? And then over time, we'll slowly lower that orbit, and eventually we'll be down in an orbit that takes only about 4 hours to go around the asteroid, and that's when we'll get our highest resolution data and all that chemistry data that we're talking about, and we'll be mapping the magnetic field and the gravity field the whole time. So yeah, that's why it's going to take us a couple of years, 26 months, to do that primary mission.
Yeah, a long journey for a lot of science.
Yeah.
Now let's get to another update from Raquel, who's live with JPL in California.
Thanks, Megan. I am in the Space Flight Operations Facility here at JPL, which operates the Deep Space Network. It consists of 3 complexes with large radio dishes that let us communicate with spacecraft that go beyond the moon. Now, these 3 complexes are strategically located in California, Spain, and Australia. They provide two-way communication and also help us track and navigate the spacecraft so we can keep them on course. And right now, the Deep Space Network is supporting over 40 missions. The Psyché spacecraft is expected to first communicate with the radio antennas in Canberra, Australia. Then data will come here to JPL. The operations team will use it to track Psyche, monitor its health, and send commands as it travels to the metal-rich asteroid. Megan, back to you.
Now, riding along with Psyche is NASA's first demonstration of deep space laser communications. Let's bring back NASA's Jasmine Hopkins to learn more.
Thank you, Megan. Yes, joining me now is Jason Mitchell and Trudy Cordes to talk to us more about the deep space optical communications, also known as DSOC. So, Jason, how exactly do these laser communications work?
Well, Jasmine, so just like on Earth, where space users are voracious for data, and so most of that data on Earth is routed through fiber optic cables with lasers, as everybody knows. We do the same thing for space users in this concept for things like DSOC, except can't tether a spacecraft to a fiber, so you have to do a free space link. And with that, there's at least 3 challenges. There's pointing becomes a challenge. You have to point very precisely. Plus, the Earth distorts optical light, right? And so you think about a hot road or the horizon of a hot road on a hot day, right? Like today, and you see that shimmer. And then 3, the signal is so faint, you literally have to count photons. So we have to have these super cooled nanowire detectors that are cooled to just about 1 degree Celsius above absolute zero. But you put that together and we get a capability to deliver data 10 to 100 times faster.
Right, so what we're doing is pretty complex. And Trudy, your directorate focuses on future technology. So how can we use DSOC in the future?
Right, Jasmine. So as Jason said, 10 to 100 times more data we're getting back. So it's very enhancing. For our friends in science, more data means more discoveries. And then certainly with all the work the agency is doing around Moon to Mars objectives, DSOC now gets into the to Mars part of that. So humans to Mars, a very realistic type of system we could use for reliable infrastructure such as advanced communication systems is absolutely enabling and going to make humans to Mars and exploration a possibility.
Exactly. I'm glad you mentioned to Mars. Jason, you are understanding DSOC on a deep level, and actually there will be something called O2O on Orion for Artemis 2. So how are they working in tandem?
So thank you. So the optical to Orion will be another optical demonstration on that vehicle, and it will. So they're different missions, so they're different implementations, but they do share a lot of common hardware, and they will use the same high-efficiency photon algorithms, right? Remember that photon-starved channel, got to count those photons. And that's how we'll accomplish that in injection or infusion into human spaceflight.
Right.
And Jasmine, just to add on, so Jason and I had the unique opportunity to go over and see O2O installed on the Artemis 2 service module yesterday. It looks absolutely beautiful. We're excited about that. We're very grateful to our friends in exploration for flying that for us to get this to an operational capability. And Jason knows what we like to say in space tech all the time. What do we say, Jason?
Technology drives exploration.
Bingo, exactly what Jason said.
Awesome.
So.
Great things to look forward to in the future, Jason, Trudy. Thank you so much. Thanks, Megan, back to you.
As you heard, laser communications will play a big role in our next mission to the moon. Let's see what else is already happening for Artemis 2.
It's a short package,
You would have thought it was launch day here at Kennedy Space Center just a few weeks ago. The Artemis 2 crew suited up in the historic Neil Armstrong Operations and Checkout Building. A test to practice a bit of what would happen before they lift off for the moon. Once their suits were on, they were off inside their brand new, fully electric crew transportation vehicles for the 9-mile drive to Launch Pad 39B. Kennedy employees waving to the crew as they drove by. At the pad, Commander Reed Weissman, pilot Victor Glover, and mission specialists Christina Cook and Jeremy Hansen took elevators to the top of the mobile launcher.
When we walked out that crew access arm, I just had images of all those Apollo launches and shuttle launches that I saw as a kid, and it was unreal. I actually had to stop and just stand a moment in the crew access arm to really let it all sink in.
The day's successful test ended in the White Room, their final stop before boarding the Orion capsule to the moon. That's your Artemis Moon Minute. If If you're just joining us, welcome to live coverage of Psyché. Liftoff aboard a SpaceX Falcon Heavy rocket is now just 10 minutes, 13 seconds away. Atop in the payload fairing is the Psyché spacecraft, which weighs just about 6,000 pounds when fueled. That's about as heavy as a large SUV. It's made up of a body and 2 solar arrays in a cross formation, and when those solar arrays are extended, the spacecraft measures about 81 feet, or the size of a tennis court. It will be propelled by solar electric propulsion and will travel about 2.2 billion miles to study the metal-rich asteroid, also named Psyché. Now, Jim, you are one of the scientists behind this mission, a mission more than 10 years in the making. How are you feeling now with 9 minutes and 30 seconds to go before
my
launch?
goodness, I have butterflies the size of pterodactyls in my stomach right now. But really, I'm thinking about the team.
Yeah.
Right? I'm thinking about the hundreds, the thousands of people around the world, across the country, around the world, who have worked so hard to get to this point. Launch is the focus of a big team effort, and I know there's lots of folks out there on pins and needles right now.
Absolutely.
But also, I think we're also just super confident in the team at SpaceX, the team here at Kennedy, to get us up there into space and give us a great ride.
Yeah, and this mission could benefit planetary science for generations. So impactful.
Absolutely. I mean, we won't get to Psyché till early 2029, right? So you think about a lot of the kids watching at home today or in school today, they're going to be the researchers who start working with the data in the 2030s and beyond. And we're going to have that data set coming in for a couple of years and hopefully learn a lot about planetary cores, the Earth's core, how planets form, and all kinds of cool things like that.
Jim, I really can't wait to see what you all uncover. Yes. You can't wait either.
I can't wait either.
Pterodactyls in your stomach. That must feel awful. And now taking us through the rest of the launch countdown are Daryl and Mick.
Thank you, Jim and Megan. Appreciate all the knowledge we are getting about the Psyché
Center
mission
core
today.
RP1 load is complete.
And there we just heard a call out that the RP1 load is complete, and that's great news. We're continuing to watch as this vehicle is tanked with propellants, 2.8 million pounds of propellants, both liquid oxygen and refined kerosene, called RP1. We've got a number of things that we are going to be looking at as we count down to the final minutes, Mick, and one of them is chilling the booster engines, transitioning the power to internal from shore power on the ground to internal to the rocket and the spacecraft.
Yeah, absolutely. As we're tanking the launch vehicle, there's also things going on with the spacecraft, and the spacecraft team is working all of their ops, transitioning to internal power, getting ready for this morning's launch. And we just heard that they confirmed communication with the spacecraft after a short transition, and we'll verify that they're on internal power here shortly. But things continue to look nominal for this morning's launch attempt.
And we're hearing, as we go along, updates about when each booster's RP1 is complete. And we will also hear when their LOX is complete. We're getting now down to the final filling of the boosters.
Engine chill has started.
Another key milestone is to pre-chill those engines. And that's critical when you're flowing super chilled liquid oxygen into them.
Yeah, we want to make sure all 27 engines are chilled to the right temperature, making sure once we get the chilled down RP1 and the densified liquid oxygen in there that things continue to work nominal from that aspect. So the team will continue to top off the LOX tanks and get ready for moving into terminal count.
We're getting ready to transition to internal power, both for the spacecraft and the rocket. That's coming up in just 20 seconds. We're watching the boosters as they fill. They are close to getting complete.
NY RP1 load is complete.
Another booster down for RP1. Actually 3 now. So now we move to the filling of the LOX and the completion for all 3 first stage boosters.
Okay, and I'm good to run that now.
Listening in for the switch to internal power. Beautiful shot of the rocket, Falcon Heavy.
Spacecraft is on internal power.
There's the confirmation. The spacecraft is now on internal power. The Psyché spacecraft that you see there encapsulated between those two fairing halves.
Vehicle tanks are pressing for strongback retract.
So there we heard the team is pressing the strongback to get ready to retract the transporter erector, or strongback as you refer to it, away from the vehicle just prior to launch. We saw a shot there at the fairing, and that structure will move here in about 10 seconds as they retract that. Things are continuing to move pretty quickly here, Daryl, as the team preps for a T0.
Strongback retract has started.
So now let's take a view up at the top of the rocket where we can see the clamp arms. They will begin to release the rocket at just about the midsection of the rocket, midway up. We're also waiting for the NLM pole, which is coming up in just a few seconds. A final check with the NASA launch manager, Tim Dunn, by launch director Mike Taylor of SpaceX.
LD, NLM, countdown net. LD. The NASA Psyché team is go for launch. Copy, go for launch.
Great news there. The spacecraft team is ready. NASA's launch team is ready.
LOX load is complete.
Yep, and there we heard a call out for a LOX load on one of the side boosters is complete as the team continues to fill the tanks and top them off, getting ready for launch. We should be hearing the other two side boosters finishing up along with stage
TY
2
LOX load
LOX
is
load complete. And there we heard the other side booster is complete with LOX load, Daryl.
These two side boosters, they'll be coming back today, so if you're here locally, you're going to get quite a show. Boosters 1064 and 1065, which have flown 3 previous missions, 2 DoD.
Center core LOX load is complete.
And 1 commercial mission. They'll be coming back about 7.5 minutes after liftoff. So look to the sky for that, especially that entry burn and landing burn. They'll make a sonic boom that you can't miss.
Yeah, absolutely. We are looking forward to those 2 boosters coming back. And as we talked earlier, that center core will be expendable. We'll use all the propellants for Psyché today. And if you look at the launch vehicle, one of the unique things about that center core being brand new and expendable is you'll notice there's no grid fins or landing legs on that. And that is done by purpose to make sure we get the complete performance out of that center core for that trajectory that Jarmaine talked about to allow Psyché to perform its mission.
Always good to save some mass when you're flying a rocket to space. And those 2 side boosters, NASA has eyes for them for the Europa Clipper mission.
We do. Actually, the side boosters will be used on a...
Stage 2 LOX load is complete.
Stage 2 LOX load complete call out there. But those side boosters will be used on a Space Force mission later this year and or maybe early next year, and then we are looking to use those as our prime side boosters for the Europa Clipper mission in 2024.
And with that call out that stage 2 LOX is complete, the Falcon Heavy is now completely tanked with 2.8 million pounds of propellants. Getting into the final minutes of the countdown now, T-minus 1 minute and 37 seconds.
Gas launch closeouts.
So you heard there the ground gas closeouts, and see that burst of LOX coming off the side of the rocket there? That is emptying out the LOX line in the transporter erector or strongback. Getting down to the final minute now.
Falcon Heavy is in startup.
Good call out that the Falcon Heavy is in startup. Now we're going to get the go at T-minus 45 seconds.
Go for launch.
We are go for launch. All systems are go to send the Psyché spacecraft to deep space.
30 seconds. Seconds.
And here we go with the final seconds of launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of Falcon Heavy and Psyché on a mission to a metal asteroid in deep space to study the building blocks of our planet's inner space.
Vehicles pitching downrange.
M1D chamber pressure is nominal.
View there from the onboard camera on the booster. Beautiful shot there as it goes through the clouds.
Power and telemetry nominal.
Over here, Joe, the power telemetry are nominal. We're also looking at the data for all 27 engines.
Falcon is supersonic.
All chamber pressures look good, and Falcon is supersonic now.
Throttling down in preparation for max Q. A moment of peak mechanical stress on the rocket.
What will happen here
Max
is
Q.
the side boosters will be at full power, and the center core will be at a reduced power to go through max Q to reduce the pressures on the structure of the launch vehicle.
Coming up in 30 seconds. We'll start getting ready to have those boosters cut off.
Vehicle's looking good, pitching down range. All telemetry looks really good so far, Daryl. So we see a beautiful view of the Falcon Heavy and center core and side boosters there. Data is looking really good.
All 27 engines of the Falcon Heavy putting down 5.1 million pounds of thrust. Standing by now for booster engine cutoff for those side boosters. The center core booster will continue on.
Booster engine cutoff.
Side booster separation confirmed.
Great shot there of the side boosters coming off the rocket.
MVAC engine chill has started.
And there we start the chill on stage 2 as we get ready for MECO on the center core. Stage 2 will continue chilling down, making sure the fuel and propellants are flowing through that MVAC, getting ready for ignition.
Those boosters will have 3 burns, 2 re-entry burns and 1 final landing burn before it comes back down at LZ1 and LZ2, landing zone 1 and 2 here at the Cape. Next up is main engine cutoff of that center booster. After that cuts off, there'll be a series of steps that will happen in close succession. Main engine cutoff. The center core stage will separate, and then we'll start the second stage burn, the first of 2 burns today.
There we see a shot inside the
shutdown.
That was a shutdown.
Looking
main
now
engine
inside
cutoff.
the booster. There you have MECO.
Stage separation confirmed.
And there it goes. You're looking at the second stage in front of you, lighting up its
MVAC
MVAC
ignition.
engine. Split screen now on your right-hand side.
Center core FTS is saved. Bermuda.
Calling out the communication stations. What a beautiful shot there, while we had it, of stage 2.
Daryl, we continue to look at the side boosters.
Bearing separation confirmed.
Boostback has been completed, and they're in extended coast right now.
And there go the fairings. Revealing Psyché to the atmosphere. You can see the fairing falling away back to Earth. SpaceX has their recovery vessel.
Vehicle is on a nominal trajectory.
Their recovery vessel, Bob, is out in the waters right now, looking to recover both of them. Getting a good burn now from the second stage. This lasts about 4 minutes. We are going out over the Atlantic Ocean, heading south towards southern Africa. On the right-hand side, you see the glowing engine of the stage 2. We've got 2 cameras there. On the left, we're tracking those boosters coming back down.
Yeah, we should see in about 20 seconds, we should see the booster entry burn, which would be the one engine on both side boosters.
Quite a clear image in space on the right-hand side. We've got clouds overhead on the left, but you can see at the center, we're tracking one of those boosters, also tracking the second stage, it looks like right there.
Yeah, all the data so far, telemetry is looking nominal. I see the telemetry chilling down the engines for that booster entry burn on the side boosters, starting up in the telemetry. Everything's looking nominal. The vehicle second stage is performing very well, and side boosters are coming back.
Boosters entry burn startup.
And there we just heard booster entry burn startup is happening. And seeing the entry burn getting ready to go on the side boosters.
Boosters entry burn shut down.
And there we saw the booster entry burn on one and shut down. And there we see booster entry burn on the second side booster and shut down.
Next burn is the final landing burn. And for
PYNY FTS is saved.
And for folks who are in the area, you end up hearing that loud sonic boom, that thunderclap, just about the time they make landing.
Stage 2 is on a nominal trajectory.
You and I here at Hangar AE, just a couple of miles away from this landing zone, we certainly hear it and feel it.
Yep, and I see now that the side boosters are supersonic, transitioning to transonic.
And that's a shot of the booster through a thin layer of clouds.
We hear the call out for transonic. Landing burn is started.
Terminal guidance.
Here it comes.
I don't know, Daryl, but that sonic boom was great for us. I'm sure Jim is excited over there. There's the second one. I'm sure the host desk over there is feeling that really well.
Literally, our monitors were shaking as both those boosters broke the sound barrier.
And we just heard booster landing confirmed, as we see on the screen, both back landing zone 1 and 2. Everything looks great. And then the call out for
Stage 2 FTS is safe.
Psyché 1, Stage 2 engine cutoff. So, Daryl, this will put us into that 45-minute coast that you and Jarmaine were talking about, allowing us to do
nominal
that
park orbit
roll.
insertion.
Absolutely, we're looking forward to that. And as you look at your screen there are the 2 side boosters on their landing pads, coming down more staggered than I'd seen them before, but nonetheless, perfect landings for them both. And now we will continue to track this right here, the second stage of the Falcon Heavy, along with the Psyché spacecraft right there looking forward. You can see the spacecraft on the right-hand side. It will be coasting now for about 45 minutes. And when we come back, we will bring you the moment of separation. In the meantime, we'll send it back to Megan and Jim at the host desk.
And if you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw a Falcon Heavy rocket launch off with Psyché, the spacecraft. Jim, speechless. speechless. Actually, you weren't speechless during the launch because you were standing next to me, and he just kept on saying, "Go, baby, go!"
Oh, it was so powerful, so incredible. Just, you know, the light, the sound, you felt it in your bones, just shaking us as this thing goes up.
I saw the range of emotions. Like, you were super excited, and then you got quiet. You got really quiet.
Well, you know, there's a lot riding on this for the whole team, right? For all the hundreds and thousands of people that have been involved with this. And it's just, what a great ride so far.
Yeah. How did you feel also hearing and feeling those sonic booms? I was kind of worried because we saw it in the video, and we were like, are we going to feel it here? And all of a sudden, boom, boom.
Yeah. That was very exciting, very exciting. So, and it's just great job landing those boosters because we want to reuse them for Clipper next year.
Yeah. Anything you want to say to the team? Again, as we just saw it lift off, you said all that hard work, all that time.
Yeah. No, this is just, it is a team effort. And, you know, we're going to be collecting this data set and studying this planetary core for future generations. Really, it's going to be spectacular. Data, images, chemical data, magnet field data, gravity data, and really, you know, we can't study the Earth's core any other way. So here's maybe how cores grow and what's happening inside our own planet.
Yeah. So the Psyché mission is going to explore the metal-rich asteroid, also named Psyché. And why don't we take a closer look at Psyché now? It was first discovered in 1852. We don't know exactly what the asteroid looks like, but scientists have combined radar and optical observations to generate this 3D model you're looking at right now. Shaped like a potato, at its widest length, it's 173 miles. That's about the same as driving from Houston
to